We want to solve AIME II 2023, and before exam of AMC for this year 2022, around 2 months ago, I released a video preparation. I told some ideas, general ideas useful in AMC, AIME, and other levels. We will use many of those ideas here. Okay, let's start. Problem number 1. It says the numbers of apples growing on each of 6 apple trees form an arithmetic sequence where the greatest number of apples growing on any of the 6 trees is double the least number of apples growing on any of the 6 trees. The total number of apples growing on all 6 trees is 990. Find the greatest number of apples growing on any of the 6 trees. Okay, suppose, for example, the numbers are like this: A1, A2, A3, A4, A5, A6, so you can say also less than or equal. Form an arithmetic sequence, the number of apples in first tree, second tree, and this. Then it says form an arithmetic sequence. Okay, so we know the formula of an arithmetic sequence is an equal to a plus, or let's say a1 plus n minus 1d. It's when you have an arithmetic sequence, use this formula, basic formula, and you can solve the problem. Okay, let's use this. The first thing we have, it says greatest number of apples growing on any of 6 trees is double the least number of apples growing on any of the 6 trees. It means what? It means a6 equal to 2a1. The next one, the total number of apples growing on all 6 trees equal to 990. So a1 plus a2 plus a3 plus a4 plus a5 plus a6 equal to 990. Now I want to use this formula, the first one. a6 equal to a1 plus 6 minus 1 times d equal to 2a1. So we conclude a1 plus 5d equal to 2a1. If we take a1 to right hand side or subtract a1 from both sides, we conclude 5d equal to a1. It is our first equation. Now let's analyze second equation. Okay, so a1, a2 is a1 plus 2 minus 1, 1d. a3 is a1 plus 2d. a4 is a1 plus 3d. a5 is a1 plus 4d. And we can write the rest here. a1 plus 5d for a6 equal to 990. Now, here, let's consider this first equation we need. Second one, we have a1, 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 3, 4, 5, 6. So it's 6a1 plus. If we factor from d, we have 1, 2, 3, 4, 5. So it will be d1 plus 2 plus 3 plus 4 plus 5 equal to 990. You can use formula for 1 to 5, or you can calculate manually. Say 1, for example, plus 5, 6, 4 to 6, 12, 15. Or you can use formula, which 1 to n equal to n times n plus 1 over 2. Now we can say 6a1 plus 15d equal to 990. Okay. Now we use first identity. Instead of a1, we replace it with 5d. So it will be 6 times 5d instead of a1 plus 15d equal to 990. Now the next one, 30d plus 15d equal to 990. In next step, 45d equal to 990. Okay, if we divide by 45 both sides, it will be 2, 90, 22. So the first variable we need is 22. If we use again first one, we want to find a1 equal to 5d equal to 5 times 22 equal to 110. Okay, we found also a1 is what, but the problem wants what? The problem says Find the greatest number of apples growing on any of the 6 trees, means A6. If we use this formula, basic formula, A6 equal to A1 plus 5D. If we replace A1 with 110 and D with 22, 110 plus 5 times 22 equal to 110 plus 110, which equal to 220. So the answer of this problem is 220. As I said, for example, when you see arithmetic sequence, use this most of the time useful. If you want to know important basic formulas that you should know for each problem, for example, when you see arithmetic sequence, use this. When you see GCD or greatest common divisor, use these forms. We have some general and famous forms. If you want to know them, feel free to send message my WhatsApp number in the description and comments. AIME II 2023, problem number 2. Recall, palindrome is a number that reads the same forward and backward. Find the greatest integer less than 1000 that is a palindrome both when written in base 10 and when written in base 8, such as 292, which is 444 in base 8. Okay, let's consider first the largest number that we can use, 999. If you want to write it in base 8, 999 when we divide it by 8, it will be 1, 19, 2, 39, 4, it will be 7, the remainder. If you divide it by 8, it will be 15, the remainder is 4. If you divide it by 8, it will be 1, it will be 7. And you use this, and this one. So 999 in base 10 equal to 1747 in base 8. So at first, the number we want to select, we consider the number of digits in base 8. Number of digits in base 8. Okay. If it is case 1, for example, suppose this variable we call it n, case 1. If n is 4, so the number in base, for example, 10, you call it ABA. In base 8, because we have 4 digits and the largest possible case is this, so the first digit only can be 1, because if it is 2, then it will be greater than 999. It should be 1, also it should be 1. And it is 7, so we can consider, for example, it is C, it is C. It is in base 8. So you should know how to change from base 8 to 10. You should multiply it by 1, multiply it by 8, multiply it by 8 squared, multiply this one by 8 cubed. So in base 10 also, we know you should multiply it by 1, multiply it by 10, multiply it by 10 squared. So 10 squared is 100, 100a plus 10b plus a equal to 8 cubed, which is 512, 8 squared, which is 64c, plus 8c plus 1. And then in next step, 100a plus a 101a plus 10b equal to 512 plus 1 513 plus 72c. Okay, so we consider n equal to 4 first because we want the problem says find the greatest one, greatest integer that is possible. So here, because the number is ABA, we should maximize A as much as we can. Also, it is equivalent to maximize C. So, but A is more important than B. Now here, on left side, we will see it is even. This part is even, this part is odd. So left side is odd, right side is odd. So we conclude that this part also should be odd. So A is odd because it is even plus what is odd? Odd. So A is odd. Now we start from greatest one, case 1, 1. If A equal to 9. If you check, for example, 9, then you should check 7, then 5. If you check one of them, then you understand how to check the others quickly. A equal to 9 will be 909 plus 10b equal to 513 plus 72c. Now, if we subtract 513 from both sides, it will be 6. 10 minus 1 is 9. And 8 minus 5 is 3. Plus 10b equal to 72c. Now, in next step here, we divide both sides by 2. Then, if we divide both sides by 2, it will be 1, 9, 8 plus 5b equal to 36c. Now 198 is 2 times 99. It's even. It is even, so we conclude that b also should be even. So b is 2b prime. So we conclude 198 plus 10b prime equal to 36c. Now if we divide by 299 plus 5b prime equal to 18c. Now here we will see it is multiple of 3. 3 divides this, 3 divides this, so we conclude 3 divides b prime. So b prime equal to 3b double prime. So 99 plus 15 b double prime equal to 18c. Also, you could, at first you say b equal to 6 times something. You could do that also. If you divide by 3, 33 plus 5b double prime equal to 6c. Also, again, we can say b double prime is 3 times, for example, b1, because it is 3 divides this, 3 divides this, so one term is left, so 3 divides also b double prime. So 33 plus 15 b1 equal to 6c. So 11 plus 5b1 equal to 2c. So let's just review the things we reached. B was 2b prime. B prime was 3b double prime, which is 6b double prime. B double prime was 3b1, so it's 3b1, which is 18b1. So because b is a digit, so the only possible case is b1 0 and b equal to 0. So if b equal to 0, a equal to 9, and here b1 is 0, so let's see c is what? So 11 equal to 2c. And we conclude that c cannot have any integer, cannot be equal to any integer, so contradiction. So case 1, a equal to 9 was rejected. You could also reject it quickly considering parity first. For example, consider 19836 their GCD, or 39672 and divide it by the GCD, and then consider the parity. But we want to just analyze to see how we should work on these types of problems. It was case 1. Now let's consider case 1-2. We said a is odd, so the next case we should check a7 because we want to find largest. After 9 we check a7. Now if we replace it, a with 7 in this equation, 707 plus 10b, 707 plus 10b equal to 513 plus 72c. 513 plus 72c. Okay, let's subtract. 707 minus this is 194 plus 10b equal to 72c. Now let's divide both sides by 2. So it will be 97 plus 5b equal to 36c. Okay, now if we consider mod 5, 97 is 2, b is 0, is congruent to 36 is 1 mod 5, c. Modulus, so much useful. So, because c is what? C is the digit here, mod 8, it can be from 0 to 7. So, it can be only 2 or 7. So, we should check only these two cases. For previous cases, also we should work on c. So, if c is 2, 97 plus 5b equal to 72. It's bad. Because this part, b is at least 0, is at least 97, but right side is 72. Now let's check C7. So it will be 97 plus 5b equal to 36 times 7. 7 times 6, 42. We have 4. 7 times 3, 21 plus 4, 25. Now we conclude 5b equal to 252 minus 97. 12 minus 7, 5, 4, 14 minus 9, 5, and 1, 155. So if you divide both sides by 5, b equal to 3, 1. Okay, b is so much large because b is digit. It should be between 0 to 9. It's in base 10. It was case 1, 1 we've checked. A9 case 1 to A7. Now let's check case 1, 3. If a equal to 5, so 100a, it is 505 plus 10b equal to 513 plus 72c. If we subtract by 505, 10b equal to 5 plus 3, 8 plus 72c. Now, we know that because let's open a new page. Okay, here we know that it is multiple of 8, it is multiple of 8, so this part multiple of 8, so b should be multiple of 4. So we can say b equal to 4b prime, so 40b prime equal to 8 plus 72c. Now we divide both sides by 8, so it will be 5b prime equal to 1 plus 9c. Now, because b is 4b prime, b prime can only be 0, 1, 2, because if b prime, for example, 3, then it will be 12. So let's check these 3 cases. So b prime, 0, 1, 2. If b prime is 0, we want to check c is what? Then 0 equal to 1 plus 9c contradiction. So here it's undefined contradiction. If b prime is 1, then 5 equal to 1 plus 9c. So 9c if you subtract by 1 is 4. It's not possible, again contradiction. If b prime equal to 2, 10 equal to 1 plus 9c. So c equal to 1. So we conclude this case. Okay, so from this case, c equal to 1. A we said is 7. From first, a is 5. Here we said. And b is what? Is 4. B prime 4 times 2 is 8. So our number was what? ABA. So ABA, the number is, through this, that shows it is a number in base 10. Also here we could draw this, means it is not product, it is a number. Then it will be 585. So the greatest number that we have is 585. This problem had a lot of different solutions. You can consider mods, for example, mod 5, mod 2, mod 8. And some solutions are faster, some of them needs more calculation. But the whole idea of these problems is this. If you want to learn other ideas, as I said before, feel free to send message to my WhatsApp number in the description comments. AIME II 2023, problem number 3. Let triangle ABC be an isosceles triangle with angle A equal to 90 degrees. There exists a point P inside ABC such that PAB. Okay, so let's draw. Okay, it is our triangle. It says PAB. This angle, for example, is alpha. PBC is alpha. PCA is alpha. And AP is 10. Now find the area of ABC. So we know if this length is A because it is isosceles triangle, it is A. Because it is right angle triangle, A is 90, you can use Pythagorean theorem. So BC squared equal to A squared plus A squared equal to 2A squared by Pythagorean theorem. And BC equal to A root 2. So we write it here, A root 2. Now let's work on angles. It is isosceles right angle triangle. It is 45. It is alpha, so it is 45 minus alpha. This angle is also 45 minus alpha because the whole part is 45. It is 90. It is alpha, so it is 90 minus alpha. It is 90 minus alpha. It is alpha, so this angle is 90. This angle is what? Alpha plus 45 minus alpha is 45, so it should be 135. Similarly, it is also 135. Now we should use sine law. As I said, some important basic things you should pay attention in AIME, AIME, Pythagorean theorem, sine law, cosine law in preparation before AIME I told. But except those, sometimes we have internal angle bisector, external angle bisector, x radius, x center. they have formula. For example, RA, its x radius of A is area over S minus A. We have a lot of formulas, 40, 50 formulas. If you want to learn them, they are useful from AMC up to IMO. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay. The problem, we want to find A. If you find A, we can find the area. A is here, it is 10. So if you know sine alpha equal to what? Equal to AP in triangle APC. Opposite to hypotenuse. AP is 10 over A. So A equal to 10 over sine alpha. So if we can find sine alpha, then the problem will be solved. So here 35 PC. Now we found an equation in terms that it contains A and sine alpha. If we use sine law in triangle BPC, then we can say PC over sine alpha equal to A root 2 over sine 135. It will be A root 2 over 135 is root 2 over 2, or you can write it as 1 over root 2. And if you multiply both numerator and denominator by root 2, it will be 2A. Okay, so we conclude PC, if we cross multiply, equal to 2A sine alpha. From here, you can say sine alpha equal to 10 over A. If we call it a star, then by applying a star, PC equal to 2A, instead of sine alpha, we write 10 over A. These A's will be cancelled, so PC will be 20. Okay, so let's write PC 20 here. Now we can find A easily by Pythagorean theorem in triangle ABC. A squared equal to 10 squared plus 20 squared. So it will be 100 plus 400. So it will be 500. So A equal to, if we take square root 10 root 5. Now the area of triangle ABC equal to A times A over 2. It will be A squared or 10 root 5 squared over 2. 100 times 5, 500 over 2, which will be 250. Okay, so the answer of this problem is 250. If you pay attention, the only thing we've used was sine law and Pythagorean theorem. Okay, at first you should try basic things. Angle chasing also before that. Angle chasing, sine law, cosine law, Pythagorean theorem, use all these things. And also we have double Pythagorean theorem is useful in many problems of AIME, AIMC. If you want to know that also, feel free, as I said before, to send message to my WhatsApp number in the description comments. AIME II 2023 problem number 4. Let x, y, and z be real numbers satisfying the system of equations. We have xy plus 4z equal to 60, yz plus 4x equal to 60, zx plus 4y equal to 60. Let S be the set of possible values of x. Find the sum of the squares of the elements of S. For these types of problem, you should use replacement. It's one of the most useful idea. I solved also many problems with replacement in my previous videos. If you saw them, you understand. At first, we look, one way is to try to combine some of them, use some creativity. But in most of these types of problems, if you use replacement without any creativity, you can easily reach the solution. So it's so much important. Let's do it. Okay. Now we want to use replacement. How? From first equation, I find z in terms of x and y. So we know 4z equal to 60 minus xy if we subtract xy from both sides. And if we divide by 4, then z equal to 60 minus xy over 4. Now we replace in second equation. So let's consider first, second, third, and now the thing here we reached was 4. If we use 2 and 4, okay, so we replace z with 60 minus xy over 4 plus 4x equal to 60. Now we multiply by 4 both sides, so And we can say 60y minus xy squared plus 16x equal to 240. Okay. Now we want to find x in terms of y. So we say x times 16 minus y squared equal to 240. We take 60y to the right hand side minus 60y. Now, if we divide, we can say x times, you can factorize 16 minus y squared. 4 minus y times 4 plus y equal to 240 minus 60y. Here we've used famous identity that a squared minus b squared is a minus b times a plus. Now I want to divide both sides by 4 minus y, 4 plus y. But here, we should check it is not 0. So, case 1. If 4y minus y is 0, then y equal to 4. The left side is 0, so right side 240 minus 60y is 0 also. So again, y equal to 4. Now, if y equal to 4, let's analyze this part. The first equation will be, first one will be 4x plus 4z equal to 60. And we conclude x plus z equal to, if we divide by 4, 50. Now if we replace in second one, if we replace y with 4z, again it will be the same thing. Let's replace, consider third equation, and replace y with 4. So it will be what? It will be zx plus 16 equal to 60. So zx equal to 50, 44. You can see that 11, 4 works. But if you want to prove completely, you can say it is 15 minus x. If you replace 15 minus x times x equal to 44, then 15x minus x squared equal to 44. Now, if we take all things to the right hand side, x squared minus 15x plus 44. If we factorize, it will be x minus 11, x minus 4. Then we conclude x is 4 or x is 11. In this case, z is 11. In this case, z is 4. And in both cases, y is 4. So we found, and we can check. If we replace, you will see all both answers satisfy all three equations. So we found two answers now for x, 4 and 11. Let's check case 2. We want to divide both sides by 4 minus y times 4 plus y. If 4 plus y is 0. If 4 plus y is 0, then left hand side, then y equal to negative 4. And left hand side is 0, so right hand side is also 0. So 240 minus 60y is 0. So 240 equal to 60y. So y equal to 4, contradiction. So it's not possible now. In case 3, we consider it is not 0. Okay? So in case 3, we conclude y is not 4 and negative 4. So we can say x equal to 240. We factorize from 60. We factor from 60, it will be 4 minus y. And we divide by 4 minus y times 4 plus y. Then we cancel 4 minus y, it will be 60 over 4 plus y. Okay, so we found, let's see what we found so far. Z equal to 60 minus xy over 4. X equal to 60 over 4 plus y. Now, we consider third equation, zx plus 4y equal to 60. Now let's replace. First part, I say, okay, it's 60. Instead of z, we write 60 minus xy over 4 times x. We replace this x with 60 over 4 plus y plus 4y equal to 60. Now, in this case, we multiply both sides by 4 times 4 plus y. So it will be 60 minus xy times 60 plus 4 times 4 is 16, y, 4 plus y, equal to 244 plus y. Now, x is 60. Let's call this one, for example, double the star. If we use double the star, we replace x with y. So it will be 60 minus 60 over 4 plus y times y times 60 plus 16 y times 4 plus y equal to 240 times 4 plus y. Okay. Now, in next step, we want to divide both sides by, for example, let's check. If we divide by 4, it will be 15, it will be 4. Divide by 4, it will be 6. Now, in next step, we divide again by 4, it will be 15. It will be divide by 4 here. We can factor from 60 from both sides, or we can divide here by 4. 15, 50. Okay, so it will be 15 minus 15y over 4 plus y times 15 plus y times 4 plus y equal to 15 times 4 plus y. Now here, if we use common denominator, 4 plus y, 15 times 4 is 60, plus 15y minus 15, it will be cancelled. So if we rewrite it, and let's multiply both sides by 4 plus y. It will be 60 times 15 plus y times 4 plus y squared equal to 15 times 4 plus y squared. Now in next step, 16 times 60 times 15, 900 plus y times 16 plus y squared plus 8y equal to 15 times 16 plus 8y plus y squared. Now, in next step, we can say 900 plus 16y plus y cubed plus 8y squared. 15 times 16, 240 plus 120y plus 15y squared. Okay, let's simplify as much as we can. So here we say y cubed, we consider this. Now let's focus on y squared, y squared. It will be minus 7y squared. We've considered that. Let's consider y, 60y, 120y. It will be plus 1 minus 104y plus 900 minus 700, 660 equal to 0. Now, here, look, because previous part, the problem is symmetric with respect to x, y, z, as you can see. It seems that when x, for example, 4, 11, 4 works, all these things, here y was 4. Also, we have cases that y equal to 11, and we should find it here. So if you check 11, you will see it satisfies this, so we can factorize, and one factor is 11 minus 11. We should factorize because the degree is 3, and we want to use quadratic formula, so we should find one root. Now, when we write 11, y minus 11, we place y squared. Then we have y cubed minus 11y squared. I want to reach negative 7y squared. I place plus 4y. Then it will be, y squared will be okay, minus 44. Then you need to reach negative 104, so you need negative 60. And at the end, plus 660 equal to 0. So first one is 0, or second one is 0. If first one 0, let's check, for example, it was case 3, case 3-1. Y equal to 11. And x was what here? X was 60 over 4 plus y. 60 over 4 plus y, which will be 60 over 15, which is 4. And z is what? 60 minus xy over 4. So it will be 16 minus 44 over 4. It will be 16 over 4. So one answer is this case 3, 2. Y squared plus 4y minus 60 equal to 0. So we can factorize. Product is minus 60, sum is 10. So we can say plus 15 minus 4. Or no, 10, 6 I think is. Plus 10 minus 6. 10 minus 6, 4 minus 60. So it is 0 or this one is 0. So the first case. Y equal to negative 10, x equal to 60 over 4 plus y. Then 60 over 4 minus 10 is negative 6 minus 10. And z equal to 60 minus xy over 4. It will be 60 minus 100 over 4. So it will be negative 400 over 4, negative 10. So it is another answer. And the last part, y minus 6 equal to 0. So y equal to 6. So x equal to 60 over 4 plus y. 4 plus 6, 10. 60 over 10 equal to 6. And z equal to 60 minus xy over 4. 60 minus 36 over 4. 24 over 4, 6. So here we found 3 x's. So you can check all answers satisfied. The answer says sum of the square of the possible cases of x. So in this case, x is 6. 6 is squared. In this case, x is negative 10. In this case, x is 4 plus 4 squared. Let's consider other cases that we found. x11, x4. We had 4 here plus 11 squared. Okay, so let's write 36 plus 100 plus 16 plus 1 to 1. 1 plus 6, 7, 1 plus 2, 3, this. So it will be 136 plus 137. So it will be 273. Okay, so we've solved this problem only with replacement. It has also easier solutions with a little creativity to combine them, but I wanted to tell you with general idea and let me tell you here, I explained for you these parts. If you don't need to explain, you can quickly write all these things and reach the answer. And the answer was 273. If you want to learn other important and general ideas, as I said before, for example, in algebra, replacement, other things, as I said before, feel free to send message to my WhatsApp number in the description and comments. AIME II 2023, problem number 5. It says let S be the set of all positive rational numbers R such that when the two numbers R and 55 times R are written as fractions in lowest terms, the sum of the numerator and denominator of one fraction is the same as the sum of the numerator and denominator of the other fraction. The sum of all the elements of S can be expressed in the form P over Q, where P and Q are relatively prime positive integers. Find P plus Q. Okay, let's consider R equal to A over B. When A and B are relatively prime means GCD, greatest common divisor, or HCF, highest common factor, equal to 1. It is in lowest. Then, when we consider 55 times R is 55A over B. Now, A and B we can simplify because it is in lowest term. The only possible case is to simplify 55 and B. So we have some cases, GCD of 55 and B. So case 1, if GCD of 55 and B is 1. Let me tell you all cases. GCD of 55 and B, because 55 is 5 times 11, it can be 1, 5, 11, because it should be a divisor of 55. 55. We should consider 4 cases. In case 1, if GCD of 55 and B is 1, so we consider 55A over B is in lowest term. It says the sum of numerator and denominator should be equal for R and 55R. So for R is A plus B, for 55R is 55A plus B. So here B will be cancelled, and if we simplify 54A equal to 0, so A equal to 0. When A equal to 0, then R equal to 0. But the problem says R positive rational number. So without loss of generality, we can consider A and B both negative or both positive. Without loss of generality, we can consider A and B are positive. Because if you negate both of them, nothing happens. So R0 contradiction. So it's not possible in this case. Let's consider case 2. If GCD of 55 and B equal to 5. So it means that B equal to 5B prime. So 55R equal to 55A over, instead of B, we write 5B prime. From here, we cancel, we divide both numerator and denominator by 5. It will be 11A over B prime. Now we know that B is not multiple of 11 because of this. So now it is in lowest term, and B prime and A are relatively prime because B and A are relatively prime. So for R, it is A plus B. For 55R, it is 11A plus B prime. B was what? 5B prime. So A plus 5B prime equal to 11A plus B prime. Now if we simplify, 5B prime minus B prime is 4B prime, 11A minus A is 10A. If we divide by 2, 2B prime equal to 5A. Okay, now we know B prime and A are relatively prime. So we know B prime divides 5A because 2B prime is 5A. So B prime and A are relatively prime by Euclid's lemma. You can ignore A, you can say B prime divide 5, so B prime is 1 or 5. 1 is not possible because if B prime is 1, then 2 equal to 5A. So B prime is 5. If B prime is 5, so then 2 times 5 equal to 5A, so A is 2. Now in this case, R is A over B, which is 2 over B prime is 5. And B was what? B was 5B prime. So 5 times 5, 25. So it is this. So the first fraction we found, and you can check 55 times R will be 55 times 2 over 25. If you divide both numerator and denominator by 5, 11 times 2, 22 over 2 over 5. So the sum of numerator and denominator here is 25, 27, here also 27. So, and the problem wants what? It says sum of all elements in S, sum of all R's that are possible. So we found one fraction, 2 over 25. Well, let's check case 3 here. If GCD of 55 and B equal to 11, then B equal to 11 B prime. This B prime is not this B prime, it's better to write B1. 55 then B R equal to 55A over, instead of B, we write 11B1. So if you divide both numerator and denominator by 11, it will be 5A over B1. Now, sum of numerator in R is A plus B, and we know B is 11B1, equal to sum of numerator and denominator in 55R, which is 5A plus B1. Now, 11B1 minus B1 is 10B1, 5A minus A is 4A. Now, if we divide both numerator and denominator by 2, let's divide, and 5B1 equal to 2A. Okay, again, we can use the same thing. We can say B1 divides 2A because B and A are relatively prime. B1 and A also relatively prime, so B1 divides 2. So B1 is 1 or 2. If we replace B1, 1, it will be 5 equal to 2A, impossible, so B1 is 2. Because B1 is 2, we can conclude A is what? 10, A is 5, and B is 11, B1, so B is 22. So in this case, R is 5 over 22. And we can check, we can say, okay, 55 times R equal to 55 times 5 over 22. If we divide by 11, it will be 5 over 2 here, 25 over 2. The sum of numerator and denominator in both cases equal to 27. So we found two cases. Now, the last case, GCD of 55 and B equal to 55. Case number 4, GCD of B and 55 equal to 55. So in this case, we conclude B equal to 55. For example, B2. Now, why I've not said B1? Because we've used B1. It's better to use new variables. Do not make a mistake for the marker if it is in solution exam, full solution exam. So here, we can say that for R it is A plus B, which is 55B2. For 55 times R, if you replace 55 times R, it will be 55 times B times A over B. B is 55B2, so it is A over B2. So then we can say it is A plus B2, and then we can cancel A, so 54B2 equal to 0, so B2 equal to 0. B is 55B2, so B is 0, but contradiction because B is the denominator of R, A over B. So the two possible cases are these, and it says sum of them. Sum equal to 2 over 25 plus 5 over 22. Now if we use common denominator, it will be 25 times 22. 22 times 2 is 44. 5 times 25 is 125. So 5 plus 4, 9. 4 plus 2, 6. 169. Over 25 times 2 is 50 times 11. It will be 550. Okay. Now the problem says in lowest term, it is in lowest term because 169 is 13 squared and denominator is not multiple of 13. So is P over Q. The answer says find P plus Q, which will be 169 plus 550. 9 plus 0, 9. 6 plus 5, 11. We have 1. 1 plus 1, 2. 2 plus 1, 7. So the answer is 719. Okay, here we worked on GCD. GCD has some important around 8 or 10 basic rules and properties. If you want to learn important rules of GCD and also LCM, feel free to send message to my WhatsApp number in the description and comments. Okay, problem number 6, AIME II 2023. Consider the L-shaped region formed by 3 unit squares joined at their sides. Like this, as shown below, 2 points A and B are chosen independently and uniformly at random from inside the region. Here, the probability that the midpoint of AB also lies inside this L-shaped region can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. For example, look, if a is b, a, b here, midpoint here is bad. But for example, if you select a and b here, it's good, a and b here, good, a and b here, good. So let's consider the bad cases. Okay, and we say the answer, if we want to find 1 minus probability of bad case, 1 minus probability that midpoint of AB is outside region, outside the region. So it means what? A and B should be in what places? If A and B in these places, it's good. If A and B, if one of them be here, it's good, because midpoint always is in the region. So the only possible case is one of them here, one of them here, that AB is bad. Now let's consider, for example, let's consider coordinates. It is 0, origin, it is 1, it is 2, it is 1, it is 2. For example, we call this one x1, x2. This x1, for example, y1, and x2, y2. And the midpoint is what? Let's consider if we connect them. The midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. So we say it is 1 minus, we should, for example, suppose A is here, B is here, and vice versa. So we have two cases because AB or BA. The probability that A is here is 1/3, because we have three parts with equal areas. If A is here, it is 1/3, and for B also we have 1/3. This part is AB or BA, the two first one, A in the region, B is in the region, and then times probability of x1. So look, this part should be here, means this point is what? This point is 1, 1. So, probability of x1 plus x2 over 2, let me write like this. x1 plus x2 over 2 is greater than 1, and y1 plus y2 also over 2 is greater than 1. We should calculate this probability, and we know here x1 is between 0 and 1 because a is here. x1, let me write, x1 is between 0 and 1. y1, because it is here, it is greater than 1, less than or equal to. b here, again, you can say x2 should be greater than 1, less than or equal to y2. Look, because we want to find area, it's not safe or important to say greater than or greater than equal, because a line, for example, like this line segment doesn't have any area. The area of the line segment is 0, so, and y2 is here for this one from 0 to 1. Okay. Now we want to calculate probability. Because x1, x2 are not related to each other, we want to focus on p of x1 and x2 greater than equal 1. So let's focus on this part. Over 2 greater than equal 1, it is equal to probability of x1 plus x2 is greater than 2. Now let's analyze. We consider, for example, this is x1, it is x2, x1 from 0 to 1, x2 from 1 to 2, and if we calculate, we will see this part. Okay, now we are here because x1 is from 0 to 1, x2 from 1 to 2, and then it says find this plus this is greater than 2. x1 plus x2 equal to 2 is equal to this line. Okay, let me show you this. And when it says greater than 2, we should calculate this area from the whole area that we have here. And obviously it is 1/2, it is a square, and we should consider this area over the square. It will be 1/2. So y1 plus y2 over 2, obviously it is 1/2, and they are not related to each other. You can say 1/2 times 1. So the answer is 1 minus 2 times 1 over 3 times 1 over 3 times 1 over 2 times 1 over 2. And we can cancel these 2 and 2. It will be 1 minus 1 over 9 times 2, 18. And we can say, okay, if we use common denominator, it will be 18 minus 1. It will be 17 over 18. And the problem says what? The problem says you can write it as m over n, find m plus n. So here, 17 and 18 are relatively prime. So the answer, which is m plus n, is 17 plus 18, which is 35. Okay, in AIME also, I told this way when you want to calculate the probability, sometimes you should use areas, sometimes you should use volumes, and explain if you want to work on important ideas of probability, expected value also useful, the rules, how you can use double counting in both probabilities, and counting in AIME 2022 also was useful. And it has 3 approaches: imagination for double counting, imaginations, graphs, and tables. 3 approaches that you can solve problems in AMC, AIME, also many problems of IMO. If you want to learn those 3 approaches, as I said before, feel free to send message to my WhatsApp number in the description. AIME II 2023 problem number 7. Each vertex of a regular dodecagon 12gon is to be colored either red or blue, and thus there are 2 to the 12 possible colorings. Find the number of these colorings with the property that no 4 vertices colored the same color are the 4 vertices of a rectangle. Okay, so look, if we color and there is a rectangle, let's draw a rectangle first and then draw the circle. Okay. Okay, we have this. Now, for example, suppose we want to analyze the bad case. For example, it is blue, it is blue, it is blue, it is blue. This equal to this, because they are parallel. This equal to this. And if we draw this, we conclude because it is 90, it is diameter. Okay, it is O. Okay, and also let's consider the intersection is this. So you will see it is a diameter, and it is a diameter that the colors are same. Okay, so we should pay attention. How many diameters are there? Look, A1 and one diameter is A1 connected to, let's see, A2. We have six ones, A1 to A7. The next diameter is A1 to A8. If you consider, I mean A1, A2 clockwise up to A12. Opposite to A1 is A7, so it is the diameter A2, A3, A7, A9, sorry, A4, A10, A5, A6, A11, A12. Okay, we have six diameters. We shouldn't have, for example, blue, blue, and blue, blue again. Then we have rectangles. So let's analyze if all of them have, how many diameters are there? Six diameters. If we have only, if we don't have any, so let's consider different cases. If we don't have any diameter with the same color, always each diameter, the first one is X, the next one is Y. So for each of them, it is R, for example, for first one, it is RB or BR. So it will be 2 to the 6, which is 64. Let's consider case 2. In case 2, we consider that all of them are xy except one. One of them, for example, equal to xx, but the other one equal to, for example, xy, and something like this. So at first, you should select the diameter that you want to have same color on both endpoints. 6 choose 1 times RR or BB, two cases. And then the others will be 2 to the 5 because RB, BR. So it will be 6 times 2 to the 6, which is 64. And it will be 6 times 4, 24. You have 2, 6 times 6, 36 plus 2, 38. Last case, case number 3. If you have two cases that have same color, but if it is XX, the next one should be YY. Or let me tell you, you should have one BB and one RR. Because we can't have two things that have BB. Again, we have this bad thing. And the other things are X, Y. So at first you should say that 6 choose 1 for BB, then 5 choose 1 for RR, then we have 4 cases that are left, 4 diameters that are left, 2 to the 4 RB or BR. It will be 30 times 2 to the 4, which is 16, which is 48, 480. And the answer is sum of all these things, 64 plus 384 plus 480. 0 plus 4 plus 4 is 8. 8 plus 8, 16, plus 6, 22, we have 2. 2 plus 4, 6. 6 plus 3, 9. So the answer of this problem is 928. So look here, we've considered different cases. We split up the problem into different cases. Before AIME 2022, I released a video about preparation for AIME. In that video, I also before BMO for UK, I said important and general thing. One part was considering when you find a problem a little hard, you consider one property and divide the problem into different cases and solve the problem case by case. And also we solved different problems in AIME 22 with that idea. You should in Harvard MIT math tournament, in Stanford math tournament, always in all years, you need to know this idea, work on different cases. You should solve around, I can say, 10 important problems in this topic. Then you will get good at these problems. Okay, if you want to know the problems that are important for this topic, feel free to send message to my WhatsApp number in the description and comments. AIME II 2023, problem number 8, let omega equal to cos 2 pi over 7 plus I times sine 2 pi over 7, where I equal to square root of negative 1. Find the value of the product of k from 0 to 6. It is the sign of product. Means for you have you replace k0 to 6 here, then multiply all of them together. Omega to the 3k plus omega to the k plus 1. Okay. So let's solve this. At first, let's analyze a little. Omega is what? Let me tell you, if xn equal to 1, then you can say the root here is cos 2 pi over n plus I sine 2 pi over n. And you can also, for example, you can consider this r. Then the roots are r, r2, r3, r cubed, r to the n. Okay? Or you can say r to the n minus 1, and one of them is 1. Instead of r to the n, you can say 1. And sum of the roots is what? Always you can say 1 plus r squared plus r cubed plus r. You can use figures r to the n minus 1. It is equal to 0. It has two proofs. One proof is you say, okay, by Vieta's formula, we know xn minus 1 equal to 0. If you have an xn plus an minus 1 xn minus 1 to a1x plus a0, it has, for example, roots r1 to rn. Sum of the roots r1, let me write r1 plus r2 to rn, you can say it is equal to negative an minus 1 over an. And here, because an minus 1 is 0, that's the reason it is 0. Also, you can consider, for example, it will be as they will be around. But the next proof is more, we can say, intuitive. But also, you can say, for example, because it is 1, the next one, for example, 2 pi over 7 is r. Then you can say, for example, r squared and all these things, r to the n minus 1. This view also good. For some problems you want to work a little intuitive thinking, it helps. And you can consider them like vectors, and then their sum will be 0. Okay? But Vieta's formula was so much better. So, here an minus 1, 0, so negative 0 over an, which is 1, negative 0 over 1 is 0. Now here, we conclude because omega is, because it is 2 pi over 7, 2 pi over n, we know that omega is root of x to the 7 equal to 1. We can say the roots are 1 plus omega squared plus omega cubed plus omega to the 4 plus omega to the 5 plus omega to the 6 equal to 0. Okay? So we have this, and if you subtract by 1, you can say omega squared, omega cubed, omega 4, omega 5, omega 6 equal to negative 1. And we will use this a lot of times in this problem. Now, let's calculate the problem. I think that problem once. Okay. So let's replace k with 0. It will be w0 plus w0 plus 1 times k equal to 1, w3 plus w plus 1, w2, w6 plus w2 plus 1, w3, which will be w9 plus w3 plus 1. If k is 4, w12 plus w4 plus 1. If k is 5, w15 plus w5 plus 1. w18 plus w6 plus 1. w to the 0 is 1, w to the 0 is 1, 1 plus 1 plus 1, 3. Now, look, if I write all of them in one line, let me rearrange them. One important thing that useful in round 1, AMC, also IMO. I can tell you exactly which IMO should use. If you want to know the IMO problem that you can solve with this idea, as I said before, feel free to send message to my WhatsApp number in the description and comments. It's Gauss idea. Gauss idea is what? The first thing that you should know. For example, if 1 plus 2, you want to calculate 1 plus 2 to 100 is what? You say it is 8. You say then I write it in reverse order. 100 plus 99 plus 1. Then if you add these two terms, 2a equal to 1 plus 100, 101. 2 plus 1, 99, 101. Plus 100 times 1, 101. So a equal to 100 times 101 over 2. We call it Gauss idea. You consider first and last, second and second from last. And here we want to use exactly Gauss idea. Means what? We want to multiply these two things, then multiply, let me write the next with other color. Second and second from last, and the last case we want to multiply with red this and this. Okay, so let's see this word. At first I calculate the green one. Means what? W cubed plus W plus 1 times W18 plus W6 plus 1. We know W is root of x to the 7. So W to the 7 equal to 1. Because x to the 7 equal to 1, W is root of this. So W to the 7 is 1. So W to the 18, we can say W to the 18 is W to the 7, which is 1 times W to the 7, 14 times W to the 4. So look, you can consider 18 mod 7 is 4. So we can say it is equal to W cubed plus W plus 1 times W4 plus W6 plus 1. Let's calculate. If we multiply W cubed to all of them, it will be W7 plus W9 plus W3, W to all of them, W5, W7, W. And if we multiply 1, it will be W4 plus W6 plus 1. And then W7 we know is 1, W9 we know is W squared because W7 is 1, W3, W5, W7 is 1, W4, W6, plus 1. So here we have 1 plus 1 plus 1, 3. Plus W, W2, W3, W4, W5, W6, you have all of them. W plus W squared plus W cubed plus W4 plus W5 plus W6 equal to 3 plus minus 1. 3 minus 1 is 2. So the product of green one is 2. Now similarly, let's calculate the next parts. And you can write in general. For example, you can say, okay, W3, for example, something times, look, 18. Let me tell you. You can say, for example, W3K plus WK plus 1 times W3. Look, it is 3 times 6, 3 times 1. 7 minus K plus W7 minus K plus 1. And you can see the product is 2 in general. And we will also use that. But because if we have only 3 cases and we've calculated 1, let's calculate the other 2 cases. Solution number 1 we can say, then I will tell you for in terms of K, if you want to find W6 plus W squared plus 1 times W15 plus W to the 5 plus 1. So we can write it as W6 plus W squared plus 1. Because W to the 7 is 1, W to the 14 is 1, so it will be W plus W5 plus 1. Now, if we calculate this, it will be W6, W7 times W plus W11 plus W6 plus W3 plus W7 plus W2, W1, W squared. Next one, 1 to all of them. It's W plus W5 plus 1. Okay. Now, W7 is 1, so it will be W4 plus W6 plus W cubed plus 1 plus W squared plus W plus W5 plus 1. Okay, so 1 plus 1 plus 1, 3 plus. You have W, W2, 3, 4, 5, 6. W squared to W6, which is negative 1 we've calculated. So 3 minus 1 is 2. On last part, we were written like this, W9, 3, 1, 12, 4, 1. W9 plus W3 plus 1. W12 plus W4 plus 1. Okay, so let's calculate this. And because W to the 7 is 1, we can replace W9 with W squared, W cubed plus 1. Instead of W12, we can write W5 plus W4 plus 1. Then we multiply W squared to all of them. It will be W7 plus W6 plus W squared. Then we multiply W cubed. It will be W8. Instead of W8, we write W1. Then W3 times 4 W7, we write 1. Instead of W7, W cubed times 1 W cubed plus we multiply 1 W5, W4, 1. Here also we can say it is 1. So it is 1 plus 1 plus 1, 3. Then you have W, W2, W3, W4, W5, W6. You have 1 from each of them, W, W squared to W6. It will be negative 1. So it will be 3 plus negative 1 equal to 2. So each of them will be 2, so 2, 2, 2. And you can say 3 times 2 times 2 times 2. 2 times 2 times 2, 8. 3 times 8, 24. Now let me explain for you solution number 2. If we want to, for example, for general things, we want to prove it is 2. Here, for example, it was AIME, and it is not, we can say, related to AIME because it is not full solution exam. We had only 3 parts, but sometimes you have 100 parts. And if you want to write, you should write for 50 times. In this problem, we've written for 3 times. Look, here, because we had 6 terms, we had 3 pairs, and we could calculate manually. But sometimes maybe you have, for example, 100 terms. In that case, you should write like this, general form. And let's analyze this. W, it will be what? W3k plus WK plus 1 times W21 minus 3k plus W7 minus k plus 1. So let's calculate it. W3k to each of them, the next one is W21, the next one is W7 plus 2k plus W3k. And when we multiply WK, it will be W21 minus 3k will be 21 minus 2k. The next one is W to the 7, the next one is W to the k. The last one is 1. You multiply W21 minus 3k plus W7 minus k plus 1. So W to the 7 is also 1, 1 plus 1. It will be 1 plus 1, 2. This one and this one. And W to the 27 also is 1. So let's write 1 plus 1 plus 1, 3. Plus. The other cases are W7 plus 2k plus W3k plus W21 minus 2k plus W to the k plus W21 minus 3k plus W7 minus k. And look, here because we were considering these, we should consider K1, 2, 3. Okay, now I want to say 1, 2, 3, 4, 5, 6. I want to say one of them is W, one of them W squared, 3, 4, 5, 6 mod 7. So now let's focus on the powers. I want to say 7 plus 2k, 3k, 21 minus 2k, k, 21 minus 3k, and 7 minus k. I want to say all of them different. Mod 3, mod 7. Mod 7, they are different. And also they are not equal to 0. So if we say this, then we have 6 terms. They will be W1 to W6. It will be negative 1 and it will be 2. So why mod 7 they are different? Let's consider mod 7. If 7 is 0, you can get rid of that. Minus 2k. K. 21 minus 3k. It will be negative 3k. 7 minus k minus k. And because we can add 7k to the negative parts, it will be 2k, 3k, 7k minus 2k, 5k, k. 7k minus this 4k, and 7k minus this is 6k. So it will be what? K, 2k, 3k, 4k, 5k, 6k. We know if ik is congruent to jk mod 7, then you can divide both sides by k. And we know because k is 1, 2, 3, I is congruent to j mod 7 over gcd of 7 and k. The formula is this. gcd of 7 and k is 1, so it is this. So I, because I and j are from 1 to 6, I equal j, so contradiction. So all of them are different. So we can say mod 7, they are equal to 1, 2, 3, 4, 5, 6. So this part is -1. So 3 minus 1 is 2. And with this way, you say, okay, it is 2, so it is 2, 2, 2, 3 times 8, 24. Okay, so 3 times 2 cubed equal to 24. If you had question about this problem or wanted to learn more things, like combination of Vieta's formula and complex numbers are so much interesting, and you can use these two things and a lot of other things, combine them and reach a lot of important conclusion. If you want to know important things that are useful in AIMC, AIME, other levels, as I said before, feel free to send a message to my WhatsApp number in the description and comments.